Hey guys, this is Dan Lattiser, and I am coming to you with Chem 125, Doane University's online class, to bring you the interactive advanced concepts video presentation for Module 2. And today we are working with observing a chemical reaction with Alka Seltzer, which is essentially citric acid and bicarbonate. And the production will be, or the reaction should produce some H2O and carbon dioxide, which creates the bubbling that you observe when you drop the Alka Seltzer in the water. The molecules are in a solid state, and when they are placed in water, they're able to move freely and react, which causes reaction. Right here we have a little lab setup. Here is a cup of water. It's going to go into this. I didn't have any food coloring, so I'm just using some stain from microbiology class. And here is your vegetable oil. So, as instructed, about maybe a quarter full of water to guesstimate. And then the vegetable oil. These materials obviously don't bind together. Water separates these little bubbles. After they've given some time, it'll be more uniform, as some of the water molecules are kind of still sitting inside of the oil. I'm going to go ahead and add our dye, and you'll see them do the same thing as what water would do. They just kind of float as these little dye balls down to the bottom. I will give this a little shake so that it can stain the water molecules. Otherwise it'll just sit there like that. I might need to use a stick to get those down. I'll add a little bit more dye. Maybe we can get a little bit more weight to break that barrier. There we go. Okay, we still have some of the bubbles in there that have not broken through, so the stain is not gonna quite reach the water. But once we get our Alka Seltzer, our citric acid and sodium bicarb going in there, that should change. So here is your Alka Seltzer. I did a brief little write-up on what we're looking at chemically. So I looked it up, and the chemical formula, as you can see, for Alka Seltzer is right there. And the reaction that we're going to be looking at is that right there. And what we're truly looking at, the reaction that you're really seeing, is this right here. The water to CO2 is the product that we're going to observe taking place. So here we go. That's a half tablet broken in two. I'll add a little bit more. And finally, I'll add the very last piece. That's a full tablet. As the acid and the base, the citric acid and the base of bicarbonate going together and producing some water, some H2O, and the carbon dioxide as a gas, and the gas is releasing, which is what you'll observe from the top. And part of one of the ways that you can measure the reaction would be to weigh this prior to the reaction, and then weighing after the reaction, which could technically be lighter because the gas is releasing. So part of the product being produced is actually going into the outside of the confined experiment because the gas is being released and there's no top on here to contain that gas. And now we see that the bubbling has stopped. So the other thing that we observed, or that I read about, and I'll attach a link to the experiment that was conducted, I guess, by the University of Michigan, put out a small PDF on a little Alka Seltzer experiment like this. And they were testing for limiting reactants and how that all worked. So you have the bicarb, and that's actually in excess. And when it's put into the water solution, it's going to be the excess reactant, whereas your acid is going to be the limiting. Now, one way that you can reverse that, what they talked about, was the use of vinegar, which is acidic, and that placing a water vinegar solution, what they did was they changed different ratios of water to vinegar. And what ended up happening with that was they were able to get more CO2 production, and that they were able to reverse this, the excess and limiting factors between the two substances. So in this case, water, no extra acidity added to it, so the sodium the sodium ends up being, or sodium bicarb ends up being the the excess. There's more of it. The citric acid burns off or reacts quicker, which can be reversed by substituting a more acidic solution to put it into. That conducts the experiment for today. And in that, so if it eventually would reach a point where you could just add, if you reverse those and then you just keep adding vinegar and keep adding vinegar, keep increasing the acidity, it doesn't matter because the bicarb has already ran out, and no matter how much more acid you end up putting into it, you're not going to get any further CO2 or water product. All right, that's it. Thanks for watching. Thanks for listening, and hope you guys have a good week. All right, take care.